2026 A-Level Combined Mathematics Paper 1 Part B Question number 15 Part B. Part A of this same question was discussed in a previous video, link in the top right, and Part C of this question will be discussed in a future video, link in the top right. Part B of this question has to do with integration and specifically includes the integration technique, integration by parts. The first part of the question says, show that the derivative of tan of x over 2 is equal to 1 divided by 1 plus cosine of x, and the second part of the question says, show that the integral from 0 to pi by 2 of x squared times sine of x divided by 1 plus cosine of x whole thing squared with respect to x is equal to pi squared divided by 4 minus 2 times the integral from 0 to pi by 2 of x divided by 1 plus cosine of x with respect to x. The question then says, hence using the result in part 1, show that the integral from 0 to pi by 2 of x squared sine of x divided by 1 plus cosine of x whole thing squared with respect to x is equal to pi by 4 times pi minus 4 plus 2 times the natural logarithm of 2. Now to start with this question, let's write down part 1 and try to find the derivative of tan of x divided by 2 with respect to x. Now for this, what we need to do is to realize that tan of x over 2 is in the form f of g of x, where the outer function f of x is simply tan of x and the inner function g of x is x divided by 2. Now considering that, as we know, whenever we have a function of the form f of g of x, the derivative of f of g of x is equal to g prime x times f prime of gx, where f prime is the derivative of f of x and g prime is the derivative of gx. Now according to that, if f of x is equal to tan of x, as we know, the derivative f prime x will be equal to secant squared of x. And if g of x is equal to x over 2, then we know the derivative g prime x is equal to 1 over 2. Now according to that, if we apply the formula, we can see the derivative of f of g of x, or the derivative of tan of x over 2, is going to be equal to the derivative of the internal function, which is 1 over 2, times the derivative of the second function, which is secant squared of the original function g of x, which is x over 2. So therefore, the derivative of tan of x over 2 is 1/2 secant squared of x over 2. Now since secant is equal to 1 over cosine, we can replace this as 1 over 2 times 1 over cosine squared of x over 2, or we can write it as a single fraction as 1 divided by 2 times cosine squared of x over 2. Now to turn this into expression that they want, which is 1 over 1 plus cosine of x, we use the double angle identity. The double angle identity says the cosine of 2x is equal to either cosine squared of x minus sine squared of x, or 2 times cosine squared of x minus 1, or it's also equal to 1 minus 2 sine squared of x. Now out of these three equations, we are going to use the second one. So taking the second one, we can see if we write cosine of 2x equals 2 cosine squared of x minus 1, and we rearrange, we can see we can get 2 cosine squared of x being equal to cosine of 2x plus 1. Now considering the form that we have here, we can see we have 2 times the cosine squared of x over 2. Now substituting that into here, we can see this will be equal, if x is equal to x over 2, then we can have 2 cosine of x, cosine squared of x over 2 being equal to the cosine of double that angle, which is cosine of x plus 1. And therefore, instead of 2 cosine squared of x over 2, we can substitute cosine of x plus 1. So doing so, we can see we get 1 divided by cosine of 2 times x over 2, which is cosine of x plus 1. And that is our answer. We can see that according to that, the derivative of tan of x over 2 with respect to x is equal to 1 divided by cosine of x plus 1. And with that, we are done with the first part of the question. Now after that, moving on to the second part says, show that the integral from 0 to pi by 2 of x squared sine of x divided by 1 plus cosine of x whole thing squared is equal to this expression right here. Now let's first write this down, and I'm going to write it as, let the integral, which I'm going to call I, be equal to the integral from 0 to pi by 2 of x squared times sine of x divided by 1 plus cosine of x whole thing squared with respect to x. Now going up, if I write down the formula of integration by parts, which is that the integral of u times v prime is equal to uv minus the integral of u prime times v, and compare it with the result that they've given us here, we can see this result has the exact same form and pattern as integration by parts. On the left hand side, we have one integral, and on the right hand side, we have uv, which is pi squared divided by 4, minus another integral, which is of the form u prime times v, where we have 2x divided by 1 plus cosine of x as the u prime times v. Therefore, even though they haven't even mentioned integration by parts, we need to realize that we are expected to use integration by parts in order to find this result. So going down, if I write down the formula of integration by parts, which is that the integral of u times v prime is equal to uv minus the integral of u prime times v, we can see in order to apply this formula, I need to have the integral on the left hand side in the form of u times v prime, where u is one function and v prime is another function, which is the derivative of the function v. Now taking a look at our function here, we can see we have x squared times sine of x divided by 1 plus cosine of x whole thing squared, and there are multiple different ways in which you can convert this into u times v prime. We could take x squared as u and then this bit as u prime or v prime, or we could take this bit as u and this bit as v prime, or we could take this bit as u and this bit as v prime, and lots of other things. Now out of all of them, if we take a look at the final answer that they're given here, we can see we have 2x and 1 over 1 plus cosine of x. Therefore, when we take u and v, we should eventually get u prime times v being equal to 2x divided by 1 plus cosine of x. Now usual strategies we have in integration by parts is to consider polynomial, trigonometric, logarithmic, and other components of functions that we can have in this function right here. And considering that the reason is because usually u and v prime will break into these types of functions. We will usually have u or v being in terms of only polynomials and the other function being in terms of only trigonometric or something like that. Now considering the function that we're given here, we can see x squared is only polynomial and the rest of our function has only trigonometric terms, and due to that we will either have u being equal to the polynomial of x squared and v prime being equal to the other part of sine of x divided by 1 plus cos x whole thing squared, or u being equal to the other part of sine of x divided by 1 plus cosine of x whole thing squared, and v prime being equal to x squared. Now out of these two, if we consider u prime times v, which is the derivative of u, times v, which is the integral of v prime, we can see in order to get 2x over here, we need to have u being equal to x squared, because then the derivative of u, which is u prime, will be equal to 2x, which will give us the 2x that we need in this integral right here. So therefore, what we need to do is to write u equals x squared and v prime equals sine of x divided by 1 plus cosine of x squared, and get that as the integral that we integrate in order to apply integration by parts into this integral right here. So therefore we can say let u equals x squared and v prime equal the other function, which is sine of x divided by 1 plus cosine of x whole thing squared. So we can have sine of x divided by 1 plus cos x whole thing squared. Now for this, in order to apply integration by parts, we need u and v prime, but we also need u prime, which is the derivative of u, and v, which is the integral of v prime. Now getting those, we can see for u prime, we can just take the derivative of u, which is going to be equal to the derivative of x squared, which is going to be 2x, but for v prime, we need to integrate v prime as the integral of sine of x divided by 1 plus cosine of x whole thing squared with respect to x. Now this is actually quite easy, even though it looks difficult. It is easy because if we substitute in 1 plus cosine of x equals u and let this thing right here, let's say instead of u we'll use t or something, let's say let t equals 1 plus cosine of x, we can see the derivative of t dt is the derivative of 1 plus cosine of x, which is the derivative of 1, which is 0, plus the derivative of cosine of x, which is going to be negative sine of x dx. And looking at our integral, we can see on the numerator we have sine of x times dx. And therefore, this integral will simply become equal to the integral of negative sine of x times dx, which is dt, divided by 1 plus cosine of x whole thing squared, which is t squared. So divide by t squared with respect to t. Now considering this integral, we can see this is equal to negative the integral of t to the minus 2 dt, and is therefore equal to negative times, and then if we integrate this, we can see we have t to the minus 1, since we have minus 2 plus 1, so minus 1 divided by minus 2 plus 1, which is minus 1, and that is the integral we get. And considering this integral, we can see this minus 1 cancel, leaving off with t to the power of minus 1. And therefore, this integrates down to t to the power of minus 1 over t, where t is 1 plus cosine of x. And therefore, v is simply going to be equal to 1 divided by t, which is 1 plus cosine of x. So we get this equation right here. And now according to that, if we substitute in integration by parts, we can see we're going to get the integral I, which is equal to the integral from 0 to pi by 2 of x squared times sine of x divided by 1 plus cosine of x whole thing squared, being equal to u times v, which in this case is u x squared times v, which is 1 over cosine of x. So x squared divided by 1 plus cosine of x, evaluated with the limits of 0 and pi by 2, so from 0 up to pi by 2, minus the integral from 0 to pi by 2 of u prime times v, which is going to be 2x times sine of x divided by, or rather not sine of x, 2x times 1 divided by 1 plus cosine of x. So therefore we have minus the integral of 2x divided by 1 plus cosine of x, which I'm going to factorize as 2 times the integral of x divided by 1 plus cos x with respect to x. Now simplifying this, we can see if we substitute in the limits here, we get pi by 2 whole thing squared divided by 1 plus cosine of pi by 2 minus 0 squared divided by 1 plus cosine of 0 minus the integral, or minus 2 times the integral from 0 to pi by 2 of x divided by 1 plus cosine of dx, 1 plus cosine of x divided by 1 plus cosine of x with respect to x. And simplifying further, we can see we get pi squared divided by 4 divided by 1 plus cosine of pi by 2, which is 0, so 1 plus 0, which is 1, so we get pi squared divided by 4 minus 0, which is pi squared divided by 4, minus 2 times the integral from 0 to pi by 2 of x divided by 1 plus cosine of x with respect to x. And therefore we can see we get integral I equal to the expression that they gave us, which is pi squared divided by 4 minus 2 times the integral from 0 to pi by 2 of x divided by 1 plus cosine of x with respect to x. And with that, we are done with that part of the question. Now moving to the next part of the question, they say, hence using the result in part 1, show that the integral from 0 to pi by 2 of x squared sine of x divided by 1 plus cosine of x whole thing squared, which is this integral right here, integral I, is equal to pi by 4 times pi minus 4 plus 2 times natural logarithm of 2. Now to get this result, we need to find the actual value of this integral right here of 2 times integral of 0 to pi by 2 of x divided by 1 plus cosine of x dx. Now to do this, I am going to define this integral as integral j and write it down separately and try to find the integral's value. So j is equal to the integral from 0 to pi by 2 of x divided by 1 plus cos x with respect to x. Now as it turns out, in order to find the value of this integral, we have to use integration by parts the second time. And this time, we have to take u as being equal to x and v prime as being equal to 1 divided by 1 plus cos x. And therefore, we have to say let u equals x, comma, v prime equals 1 divided by 1 plus cos x. Now given this, in order to apply integration by parts, we also need u prime and v. And out of these two, u prime is easy to find, since all we have to do is to take the derivative of u equals x, which gives us u prime equals 1. Now for v, we need to go back and use the result found in part 1 of this question. So in part 1, we found out that the derivative of tan of x divided by 2 is equal to 1 divided by 1 plus cos x. And right now, we have v prime equals 1 divided by 1 plus cos x. Therefore, we have v prime being equal to the derivative of tan of x divided by 2. And according to that, we can see that tan of x divided by 2 must be equal to the original function v. Now using this result, if we go down, we can directly write that if v prime is equal to 1 divided by 1 plus cos x, then we can say directly that v must be equal to tangent of x divided by 2. But here we have to mention that this comes from the result in part 1. And with that, we have u, v, u prime and v prime, and can now apply integration by parts. So according to integration by parts, our integral j, which is the integral from 0 up to pi by 2 of x divided by 1 plus cos x with respect to x, is equal to the limits of uv, which is going to be the limits of x times tangent of x divided by 2 from 0 to pi by 2, minus the integral of u prime times v, which is the integral from 0 up to pi by 2 of u prime, which is 1, times v, which is tan of x divided by 2 with respect to x. So therefore, we get this integral being equal to this. Now if we simplify the limits here, we can see we have pi by 2 times tan of pi by 2 divided by 2 minus 0 times tangent of 0 divided by 2, which is 0. And then on the other side, we have the integral from 0 to pi by 2 of tangent of x divided by 2, which in order to get its value, we have replaced this with sine of x divided by 2 divided by cosine of x divided by 2 dx. Now taking the first bit, we can see the first bit is equal to pi by 2 times the tangent of pi by 4, which is equal to 1, which is equal to pi by 2 minus 0. So we have pi by 2 minus 0, which is pi by 2. And then we have pi by 2 minus this integral right here, which in order to find its value, we have replaced x divided by 2 by a different variable. So I'll replace it with u. So I'm going to replace it with u by saying let u equals x divided by 2, which gives us du being equal to dx divided by 2, and hence dx being equal to 2 times du, so 2 du. We also have x equals 0, which gives u equals 0, and the other limit of x equals pi by 2, which gives u equals pi by 4. Now according to that, we can see the integral j is going to be equal to this limit, which is pi by 2 times 1 minus 0 pi by 2 minus the integral from 0 up to the other limit of pi by 4 of sine of u divided by cosine of u times dx, which is 2 du, so times 2 du. And here I'm going to take the 2 out and write this as 2 times sine u by cos u du. Now here we can see j is going to be equal to pi by 2 minus 2 times this integral, where here we have cosine of u on top and cos u on the bottom. Now sine u is equal to the negative derivative of cosine of u, since the derivative of cosine u prime, is equal to negative sine u. Due to this, if we instead write this negative 2 integral of 0 to pi by 4 of sine u divided by cos u du as plus 2 times the integral from 0 to pi by 4 of minus sine u by cos u du, then we can see we can write this as being equal to pi by 2 plus 2 times the integral of 0 to pi by 4 of the derivative of cosine of u divided by cos u du. So cos u prime by cos u du. And this integral right here is equal to the natural logarithm of the modulus of the denominator function. And therefore I can replace this by natural logarithm of modulus of cosine of u integrated with the limits of 0 to pi by 4. Now finally, if we apply these limits, we can see we get j being equal to pi by 2 plus 2 times the limits of natural logarithm of cosine of pi by 4 minus the natural logarithm of modulus of cosine of 0. Now subtracting these two, we can see we get pi by 2 plus 2 times natural logarithm of cosine of pi by 4, which is equal to 1 over root 2. So natural logarithm of 1 over root 2 minus natural logarithm of cosine of 0, which is natural logarithm of 1, minus natural log 1. And simplifying, we can see we can write this as being equal to pi by 2 plus 2 times natural logarithm, and instead of 1 over root 2, I can write this as 2 to the power of negative 1 over 2 and minus natural logarithm of 1, which is 0. So minus 0. And simplifying this, we can see we get pi by 2 plus 2 times, and if we take this power to the front, we have minus 1 over 2 times natural logarithm of 2, which finally simplifies down to pi by 2 minus, and this 2 cancel, leaving us with minus natural logarithm of 2. So j is equal to pi by 2 minus natural logarithm of 2. Now going back up, we can see since I is equal to pi squared over 4 minus 2j, we can write I equals pi squared over 4 minus 2j, which substituting in we get pi squared over 4 minus 2 times pi by 2 minus natural logarithm of 2. And simplifying, we can see we get I equals pi squared over 4 and then minus 2 times pi over 2 or minus pi, and then minus 2 times minus natural logarithm of 2, which is plus 2 times natural logarithm of 2. And this simplifies down to I equals pi times pi minus 4, because if you factorize this, take it under a common denominator, we get 4 pi here, and factoring out the pi, we get minus 4, divide by 4, pi by 4 times pi minus 4, plus 2 times natural logarithm of 2. And this expression is exactly the expression that we were given in the question. So now with that, we are done this question and can finally go up and discuss the marks awarded for this question. So at the start of the question, when you find the derivative of tan of x over 2 correctly as half secant squared of x over 2, you get 5 marks. After that, when you apply the double angle formula and convert it into 1 divided by cos x plus 1, you get another 5 marks. Now after that, in the second part of the question, when you apply integration by parts for getting the correct u and v prime and finding the corresponding u prime and v correctly for all of these 4, you get 10 total marks. After that, for then integrating, when you apply integration by parts and get this formula right here, for getting this correctly, you get 10 total marks. After that, when you then substitute in the limits, simplify, and eventually get to the form given in the question of pi squared over 4 minus 2 times the integral from 0 to pi by 2 of x divided by 1 plus cos x dx, you get another 5 marks. Now after that, when you take this integral and apply integration by parts for a second time, like so, for getting the correct u, v prime, and then finding the u prime and v corresponding with that, and showing that v can be found from the result in part 1, you get another 10 total marks. Now after that, in the last part, when you then substitute in integration by parts like so, and get this equation right here, you get 5 marks. And after that, when you simplify down and get this form of j equals pi by 2 minus 2 times the integral from 0 to pi by 4 of sine u over cos u du, and then you find that integral's value separately for getting that integral correctly as the integral from 0 to pi by 4 of the natural logarithm of the modulus of cos u, you get 10 total marks. Now after that, when you simplify down and eventually get the final answer of pi by 4 times pi minus 4 plus 2 times natural logarithm of 2 by substituting everything back in, for doing that and getting the final answer, you get another 5 marks. And that is the end of this question. So I hope you enjoyed. If you have any questions or feedback, post them in the comments down below. Thank you for watching and goodbye.